Hi there, my name's Ed Langley, Engineering Manager at Witekio UK, and with me I've got Amanda McGregor. Amanda leads product innovation for NXP's advanced edge processors. Hi Amanda.
Hi Ed, thanks for having me on the podcast today.
We're here today to talk about security on NXP i.MX8 MPUs. So Amanda, can you define secured by design for us, please?
Absolutely, Edwin. It's a great question. So when we think about security, first, what we really like to state is that security really is only as strong as the weakest link in the system. And what we've realized is that at every product development stage, you can either enforce security or potentially have it be compromised. That's why we believe so strongly in building products from the ground up with this security by design approach that addresses security across the entire development cycle. And when I say entire development cycle, I really mean from concept to product release and even beyond release into the longevity of the product when it's in the world. What I mean by that is that security isn't bolted on later. And in fact, when we look at some of the recent articles, and one in particular that Microsoft wrote quite recently, they state that there are 7 properties of highly secure devices, and that device security is first and foremost rooted in hardware, and that's NXP's domain of expertise. So secure by design at NXP means that we have proven processes that are designed to increase the security maturity level of the device, and it starts at the very beginning of the product requirements definition. So that requirements definition phase is when we're collecting market input and customer input and industry trends and defining what the product should do. And when it comes to security, there really is no one size fits all. Our first step and our overarching goal is to understand the customer applications and the use cases. Any regional security requirements. An example of this is OSCA in the Greater China region, or FIPS, which is largely North America based. And then trying to understand the hardware implications of how those necessary certifications can be met and how do we build a compliant product. So that's all up front during the product requirements gathering stage. And then during the product development, our team of security experts, we have a very strong team at NXP. They really work with us in lockstep mode with both our hardware and our software design engineers. And along the way, they're performing these continuous reviews and assessments of the device's security, concept, the architecture, the design and implementation. And then we also have an internal vulnerability lab. And so they'll perform more detailed testing, penetration tests, simulations, silicon analysis when we get that first silicon back. And so this collection of experts is really working lockstep along every gate and milestone of the development process. We also ensure our process aligns with emerging security standards and really ensuring that we're looking at customer use cases today and what they need to be implemented in sort of that 1 to 2 year range, but then we're also thinking bigger of, where is this going to evolve in the future, and making sure we put those hooks in now so that we can be compliant for many years to come. So that's really how we think about secure by design from the SOC perspective, Ed. Okay.
So given, as you say, that one of the first steps in that process is with the hardware, a major line of hardware from NXP is, of course, the i.MX8. How would you say could the i.MX8 fit easily into a secure by design approach for your customers?
Yeah, again, a very good question. And what I want to do here is take a little bit more of the OEM view for this question, because we have a very rigorous, process-oriented way of creating a secured by design product. Now, when we talk about integrating this into a secure by design end product that our OEMs would build, this is where we really want to talk about how the OEM can take what we've been building and then integrate it into their larger system. So first, the OEM really needs the device level open source software enablement, documentation, and the knowledge and the support from our NXP experts to really get them up and running with the product. We have a lot of capabilities on our parts. We enable them through our base enablement platform. We need to help our OEMs with the out of the box, the ease of use, and get them starting with their product prototyping. Because when you think about it, it does seem like a very simple step to enable this capability. So we've talked about how our i.MX8 really adheres to NXP principles of secure by design and how we implement that methodology. Where I want to take this question is a little bit more around what an OEM needs to do to create a product that is secured by design. So really, when you think about it, the OEM would get their hands on an i.MX8 product. It might be an EVK. They might already have their own prototype hardware built. What we need to enable them to do is get access to the device level open source software, the documentation, and then our team of knowledgeable experts who can help them implement the security component in their system. These are really sort of the enablement basics for how the OEM can get started with their product prototyping. And the security ease of use is really important here because what seems like a very simple step can become incredibly complex without the right security enablement and support. And that's what NXP does very, very well. Beyond the prototyping stages, the OEM needs to then implement a complete secure system in terms of the entire lifecycle management. So they'll need services to enable device level key provisioning, commissioning, lifecycle management, and even product decommissioning when you consider the entire lifecycle of really how long a product would be in the field for. This can be implemented by the OEM themselves if they have the security know-how, or it could involve a third party as part of a broader ecosystem. And so the key point is that security by design from an OEM point of view really must implement the fundamental product level security, but also this concept of automated renewable security. And what this enables is continual device level security upgrades as the product is in the field, as new security threats are identified. That becomes even more important because we build industrial products, we build IoT products, and they will live for 7 to 10 years, even longer. And so when you think about the number of emerging threats that can happen during that time frame, you really need to ensure that the platform has this concept of continual security upgrades along the way. And so, when we think about the secure by design approach, it really starts at the hardware level with what we build with our SoCs. It transfers to the OEM enablement. And then, the OEM has that critical piece of really ensuring the product in the field continues to be secured by design through its product lifecycle.
Given, as you say, the OEM enablement, and you mentioned key provisioning there, just to dig into a bit more detail, could you tell us about some of the major security features offered by the i.MX8 line?
Absolutely, and I'll try not to go into too many acronyms here. And there are a lot of words that I think will resonate with people listening to this, that understand the technology. So when we think about the capabilities that are essential to make the product secure-able, these really include the concept of secure boot. So ensuring that the software running on that platform is the software that's intended to run on that platform, that it's not been tampered with. So that's very important. Cryptographic acceleration, the ability to implement true random number generation when developing these keys that are used to secure data and create that privacy. The ability to securely debug the platform. And then TrustZone. We have many applications that require virtualization where you'll have more of an open operating system running, perhaps on one core, and then more of a real-time trusted execution environment that really has to be protected. And so we implement TrustZone on our platforms to enable that concept of virtualization. Ed, we recently announced our i.MX8 ultra-low power applications processor, and that's taking our concept of security one step further. It integrates a secure enclave, and so what that does is provide a dependable hardware root of trust and runtime attestation. So really, as the product is living and existing in this broader connected environment, it's really providing this constant way of determining its authenticity to be a part of that network, and that's all enabled in our secure enclave.
Okay, is that sort of attestation, as in sort of reporting into a server on the cloud?
Exactly. So, and then you need to have that cloud to edge, security connection, which we have a very broad ecosystem for that. But absolutely right. I mean, you need to be able to report real time that this device is authentic and it's approved to be a part of this system. And we actually have other capabilities that involve intelligent tracking and management of power transitions and power states on the device to really help minimize the attack surfaces. And this is really important, as we're connecting so many devices in the field, because by nature of doing that, you're expanding the number of attack surfaces. And so with this special hardware, we're able to really reduce the risk of that.
Well, that is especially interesting because we see a lot of customers now who want to manage a fleet of devices. And as part of that, yes, they definitely want device attestation into the cloud to make sure that they're all running valid firmware images and not presenting any kind of security risk from the device side. So.
Yeah, absolutely. And I think we find that, there are so many certifications out there in terms of, you've got FIPS, you've got CSIP, which is for IoT platform security. And so they're really mandating these capabilities because they need to be able to certify products that can meet those criteria and can provide that assurance. And so that's absolutely critical, as you mentioned, fleets of devices. There needs to be a way to certify that they're secure. And so all of these hardware capabilities are essential to meeting those common criteria.
Is that as a use case that was especially considered on the ULP?
The fleet of devices, or?
Well, the secure enclave, is that something that is new to the ULP?
It is new to the ULP, and we're talking a little bit more about the i.MX8 today, and obviously the 8 ULP is part of that story, but with the evolution of the 8 ULP and the secure enclave, this is really where we're heading moving forward into our next generation of products. We recently announced our i.MX9 series that will also have a secure enclave. So we believe so strongly in the importance of security that we're continuing to invest in it heavily and create new capabilities moving forward with our portfolio.
Perfect. From experience, I could say that Linux and the i.MX line of MPUs has incredibly mature Linux support. What would you say are the watch points when you want to integrate security onto a Linux platform?
So when we think about how to integrate security in Linux, it really comes down to using standard or well-established open source APIs. That's really essential to simplifying the ease of use or the enablement that OEMs would see. And so when we talk about hardware cryptographic acceleration, some examples of how we might implement that using standard APIs or examples is implementing the key protection feature into a standard Linux disk encryption routine. It could be integrating it into the trusted execution environment that I mentioned earlier for virtualization, or the use of a standard platform security architecture API to expose these cryptographic functions and make them usable by the end user or by the application. So really it's about providing the APIs, the hooks into the underlying hardware, so that OEMs can easily access that capability. Code examples help. We have quite an extensive set of Linux documentation, security documentation. So it's sort of a combination of, examples, APIs, and supporting documentation. And then when we think about what some of the watch points are when we integrate security, or when our customers integrate security into their platform, OEMs really need to first be on the lookout for secure boot and the entire chain of trust. It's the fundamental base of the security assurance for an edge connected device. And then when you think about secure boot, it shouldn't just stop at the initial bootloader, though that's really sort of the core part of the system. But secure boot should also carry on up to the application layer itself. Second, you have keys and data storage. So protection for keys and data should be tightly coupled with a device root of trust. And the usage of the keys should be restricted as well. And then you have, for example, the use of a trusted execution environment, a secure enclave, or even a secure element. And that's really key to protecting the sensitive data, which might be a cryptographic key that's used broadly in the system. And so I think, Ed, the specific implementation for a customer will really depend on their overall security requirements for the product. And then, continuing that lifecycle management through the over-the-air updates. So it's really quite complex. The implementation with Linux, but hopefully, through these examples, I've outlined some of the areas that we're assisting our customers with implementing their security, and then, what are the considerations for them as they put their product into the field.
So Amanda, as we've seen, with each generation of the i.MX line, the range of capabilities and functionality seems to get more comprehensive and wider ranging. Have you seen any particular applications from NXP's customers or OEMs which sort of have a combination of using the wide range of features offered by the chips, but also require a fully secure design? Any kind of particular use cases you've seen that spring to mind?
Yeah, many, and I'll give a couple of examples, but I think first, it's really important to sort of state that really all products being designed today should put security in their design spec. And for many obvious reasons, but also, Europe has GDPR and California has the CPRA, all to do with consumer privacy. There are other emerging data privacy concerns as well. And, in terms of security, there will be more enforcement in the future, since I believe security breaches are up roughly 67% in the past 5 years. Now, there are a lot more connected devices out there, but with that alarming statistic and then regulations coming into play, I think really every OEM is looking much more closely at security and how to implement them in their products. When I think of a couple of examples that come to mind, I think obviously consumer devices in the home, we're doing a lot more with smart video surveillance, with smart thermostats, with voice-assisted devices. And so consumer privacy is really important. And securing that data is really important. So certainly that's one example I think we can all relate to. But then I think about other examples, and they could be industrial warehousing, inventory management, robotics. That has potential safety implications, and there's a lot of data that needs to be secured in that environment. So we're looking at sort of two quite extremes here, consumer privacy, industrial privacy, and security. But you can see how broad a span there really is with security and what needs to be considered. And what's really exciting with the i.MX product line is we cover all of those applications, as you mentioned, because we're very broad. We can be designed into any one of those applications. And the fact is, having this secure by design fundamental approach means that whether you're building an industrial robot or a consumer toy, the customers can access this security. It's available for them to design into their product.
It's funny you say consumer toy, because it's still quite important to have that security, even in the sort of what you'd traditionally consider as not a safety critical product. But there's been a few breaches over the years of toys that we've seen in the media, and for security that can be considered, an even more critical application, because if the device is in the hands of children, for example, that is important.
Absolutely, and I think that's you've really nailed it there, because we're talking about safety, industrial safety. People could come to real harm, and so we want to really try to ensure that we're building the most secure, safe products that we can. But then, consumer privacy and our data, you and me, right? The data that we have is really important, and we want to keep that secure. And so, it's critical that we enable the OEMs who make these products to really put their best foot forward and really create the most secure product they can.
Cool. And you mentioned MIPS before, and a few other standards. We've been working through a project here where we've been considering which standards to get certified against for a particular product.
Mm-hmm.
Would you say that, given that you've put consideration in at the point of designing the system on chip, do you think that gives customers a head start when it comes to looking for certifications?
Yeah, great question. Absolutely, it can. And there are a lot of common elements to these security certifications that come down to sort of the hardware level. And there are different, within these certifications, there are different levels that can be attained or sort of secured. But what we do with our products is going through these vulnerability assessments. We often go through certifying pieces of our SoC, or the secure elements of our product. We do go through those certifications, and so we can provide some level of reassurance to customers who are developing with our products that the SoC itself can meet those requirements. Now, the OEM is responsible for the complete platform certification, clearly, but for them to design us in knowing that the SoC can meet those requirements is very reassuring. Absolutely.
Amanda, thank you very much for those comprehensive answers, and thank you for being with me today.
Thanks, Ed. It was a pleasure to be here.